So in the last class we have completed one topic on forced oscillator. So there we have derived the equation of motion for a forced oscillator. So here also I am going to write the same expression once again. So this is nothing but the equation of motion of a forced oscillator. So this is nothing but the equation of motion of a forced oscillator. So where the multiplier of sine, nothing but this one. Okay. So this one is nothing but the amplitude. So from this equation you can see that the amplitude of the forced oscillator not only on the friction, nothing but the quotient of friction of the medium, it also depends on the angular frequency of the applied external force. Okay. So here this is nothing but the amplitude. So here I am going to write the expression for the amplitude of the forced oscillator. Okay. So amplitude of the forced oscillator is given by F divided by under root of omega square minus p square whole square plus 4b square p square. So this is nothing but the amplitude of the forced oscillator. Okay. So amplitude resonance means we have to derive a condition for the frequency of applied external force where the amplitude becomes maximum. So from this expression, so to get the amplitude maximum, the denominator should be minimum. Okay, if the denominator is minimum, then amplitude is going to be maximum. Okay, so here I am going to write for a maximum. Okay, so in order to get the maximum amplitude, the denominator. Okay, so what is the denominator here? So that is omega square minus p square whole square plus 4b square p square. Okay, so this should be minimum. So if the denominator is minimum, so automatically the amplitude, because it is nothing but the reciprocal of this term, so if the denominator is minimum, therefore automatically the amplitude is going to be maximum. Okay, so here the denominator should be minimum. Okay, so denominator should be minimum means here the denominator is nothing but under root of omega square minus p square whole square plus 4b square p square. Okay, so that means, okay, so the denominator, so this denominator should be minimum. Minimum means the value, if it is equals to 0, so 1 by 0 becomes equal to infinity, that means amplitude becomes equal to maximum. So to get the amplitude maximum in case of a forced oscillator, the denominator should be minimum. So the minimum value I am going to take here is 0. Okay, therefore under root of omega square minus p square whole square plus 4b square p square should be equal to 0, or okay, omega square minus p square whole square plus 4b square p square equal to 0. Okay, so this is nothing but minimum. And every time remember one thing, so whenever you are talking about minimum or maximum, so those values are treated as constants. Okay, so minimum means it is a constant. Okay, for example, if you are writing a exam, the marks are nothing but 100. Okay, so maximum marks are nothing but 100, which is constant. Okay, and minimum marks are nothing but 0. So every time when you are talking about minimum or maximum, these are nothing but extreme values, so which are going to be constant. So here minimum means it should be a constant. Okay, so as you know, the differentiation of a constant is nothing but 0. Okay, so here I am going to differentiate this one. So differentiating with respect to p, okay, omega square minus p square whole square plus 4b square p square. Okay, so it is a minimum, this quantity is minimum, so minimum means it is a constant and the differentiation of constant is 0, therefore it should be equal to 0. Okay, so first term it is a function of p, second term it is also a function of p. Okay, so differentiating the first term only, so this is nothing but similar to that of x square. Okay, differentiation of x square is nothing but 2x, therefore 2 into omega square minus p square into differentiation of this inner term. Okay, so differentiation of omega square with respect to p, therefore it is 0 because omega does not depend on p here, nothing but the first term is not related to p. Okay, minus of, So differentiation of second term with respect to p. So that is nothing but minus 2p plus 4b square. So differentiation of p square is nothing but 2p. So that should be equal to 0. Okay. So here 2p, okay, are omega square minus p square. Okay. So this is nothing but 2 into omega square minus p square. So which is equals to minus 4b square. Here also we have minus, so minus minus gets cancelled. Therefore this is nothing but equal to 4b square. Or so here 2 and 4, that is nothing but 2b square. Okay. So here I am going to write for p square. Therefore omega square minus 2b square equal to p square. Or this p equals to omega square minus 2b square under root. Okay. So this is nothing but the condition. Okay. So p equal to under root of omega square minus 2b square. Then okay, the amplitude. Okay. So the amplitude capital A becomes equal to maximum in case of forced oscillator. So in case of forced oscillator, when the applied external force angular frequency P becomes equal to under square root of omega square minus 2b square, okay, then the amplitude of the forced oscillator becomes maximum. Okay. So here omega is nothing but the natural frequency of the oscillator and P is nothing but the angular frequency of the applied external force, and B is related to the frictional coefficient. Okay. So if I neglect the friction, okay, if we neglect the friction of the medium, okay, so if we neglect the friction of the medium, then the P, okay, under root of omega square minus of 2b square, so which becomes equal to omega. Okay. So actually to get the maximum amplitude in case of a forced oscillator, the applied force frequency P, angular frequency P should be equal to under root of omega square minus 2b square. So this is the condition to get the maximum amplitude. So meanwhile, at the same time, if we neglect the friction offered by the medium, so that is carried by the constant B. Okay. So if we neglect the friction, therefore you are not going to find 2b square here. So under root of omega square is nothing but omega. Okay. Therefore at P equals to omega, so A becomes equals to the maximum. Okay. So here we have neglected. So what we have neglected? Okay. So neglected the friction of the medium we have neglected. So when P becomes equals to omega, the amplitude becomes equals to maximum. So at this frequency the amplitude is going to be maximum. So what is the value of this maximum value we are going to write over here? So the amplitude of the damped harmonic oscillator is nothing but A divided by under root of omega square minus p square whole square plus 4b square p square. Okay. But when the applied external force angular frequency becomes equal to natural frequency of the oscillator, the amplitude becomes maximum. Okay. Therefore, so here the amplitude becomes maximum when the natural frequency of the oscillator and this external force frequency both becomes equal. So here plus 4b square p square. So this term gets cancelled. Okay. Therefore you have f divided by under root of 4b square p square. So which is equals to f divided by 2bt. Okay. Therefore the maximum amplitude of a forced oscillator A max equals to f divided by 2bp. So at the external force frequency becomes equal to the natural frequency of oscillator. Okay. Then you are going to get the maximum amplitude. Okay, so this is nothing but the amplitude resonance. So then we will be moving into the next topic of the same oscillator. So that is velocity resonance. Okay, so velocity resonance, nothing but at what frequency the velocity of the forced oscillator is going to be maximum, we have to find out that one. So again I am going to write the equation of motion of a forced oscillator. So f divided by under root of omega square minus p square whole square divided plus 4b square p square. So sine of pt minus the phase theta. So this is nothing but the displacement, the instantaneous displacement of the forced oscillator. So to get the velocity, so velocity is nothing but the rate of displacement. So dy by dt or d by dt of here substitute this value y. So f divided by under root of omega square minus p square whole square plus 4b square p square sine of pt minus theta. Okay, so here the differentiation is with respect to t only. So this is the term which is related to time t. Okay, the remaining will be treated as constants. Therefore velocity u equals to f divided by under root of omega square minus p square whole square plus 4b square p square, it is constant. Okay, so differentiation of sine, so that is nothing but sine pt minus theta. Okay. So u equals to f divided by under root of omega square minus p square whole square plus 4b square p square. So differentiation of sine is nothing but cos. So cos pt minus theta. So differentiation is with respect to t. Therefore p will be treated as constant. Therefore fp divided by. Okay. So this is nothing but the expression for the instantaneous velocity of the nothing but forced oscillator. Okay, so here this term, okay, so this is nothing but the term which represent the magnitude of the velocity. Okay, so the magnitude of velocity of the forced oscillator. Okay. So velocity resonance means at what particular external frequency does this velocity is going to be maximum, we are going to find out. Okay, so at what p value, okay, this velocity going to be maximum. Okay, so that is called as velocity maximum, nothing but velocity resonance. So here I am going to rewrite this amplitude. Okay, so I am going to rewrite, just only I am going to take the amplitude. So fb divided by, so this is nothing but the amplitude. So I am going to rearrange this equation, omega square minus p square whole square divided by p plus 4b square p, just only 4b square. So p square I have taken as common. Okay. Just wait. Sorry. So here I have taken this p square is common. So here I am going to consider just only the magnitude. So this is nothing but the quotient of cos, which is nothing but the velocity maximum, nothing but velocity, instantaneous velocity of the damped oscillator. So velocity resonance means we have to find out a value for p, where p is nothing but the angular frequency of external force. Okay, so we have to find out the value for p where the amplitude, nothing but the velocity becomes maximum. So this is nothing but the magnitude of the velocity. So this is nothing but magnitude of velocity. So we have to find out the value for p where it becomes the velocity becomes maximum. Okay. So from this equation, to get u equal to maximum velocity. Okay. So u equals to maximum velocity. So the denominator. Okay. So the denominator should be minimum. Okay. So the denominator should be minimum. So here you can see it is a sum of two terms. Okay. First term plus second term. So it is a sum of two terms. Suppose if I remove one term. Okay. Suppose if I remove one term, automatically the denominator is going to be reducing. So if the denominator is reducing, then velocity becomes equal to maximum. So here also I am going to do the same thing, because the denominator is nothing but it is a combination of two terms. Okay. So it is first term plus second term. Okay. So if I want to remove the first term, then automatically the denominator value is going to be decreasing. So if denominator is decreasing, then u is going to be increasing. Okay. So that is omega square minus p square okay, divided by p should be equal to 0. Okay. Or omega square minus p square whole square equal to 0. Or omega square minus p square equal to 0. Or okay, omega square equal to p square. Or omega equal to p. Okay. So omega equal to p means when, okay, the natural frequency of the oscillator omega. So when the natural frequency of the oscillator omega becomes equals to the frequency, the angular frequency of the external force, then automatically the amplitude becomes equal to maximum. Okay. So this is called as the velocity resonance. So where if the applied external force angular frequency becomes equal to natural frequency, the velocity of the forced oscillator becomes equal to maximum. So this is called as velocity resonance. Okay.